Hello, my dear people. Welcome to part 2 of 6.1. Last week, in the first part of this unit, what we did is we did these first 3 rules of exponents. Today, what we're going to do is we're going to do the fourth, that's not a 4, the fourth, the fifth, the sixth, and the seventh. So that is this week's fun. I'm going to do this in 2 videos. I'll probably do rules 4 and 5 in this first video, and then in the second video, I'll do numbers 6 and 7. All right, very exciting. Here we go. These, by the way, are my favorite colors. I love yellow on top of maroon. I don't know what it is about yellow and maroon. It just kind of gives me a sense of peace. So I don't know. It's also the colors of my favorite soccer team. That's probably why. But anyways, let's go. Here we go. The power of a product. So let's talk about some vocab first of all. You guys remember what a product is? It's a multiplication, right? So for example, when I do the power of a product, I'm doing the power of a multiplication. So for example, if I had like 2 times 3 squared, that is the power of a product. You can tell what the answer is on this one, hopefully pretty quickly, because 2 times 3 is 6, and 6 squared is 36. So let's see how this works out if we expand it. So if I were to expand it, it would be like 2 times 3 times 2 times 3, right? Which is basically 2 times 2 times 3 times 3. Remember, when you multiply, it doesn't matter what order you do it in. So I'm taking those 2 2s and putting them in the front, and the 2 3s and putting them in the back. Now that, of course, equals 2 squared times 3 squared, which equals 4 times 9, which is in fact 36, as we said. But what I want to point out to you is this idea right here. Why did I do all the whole expansion? What I basically want you to see is I want you to see this right here as compared to the original question. Do you notice basically that what's happening is this exponent is being, in a sense, distributed to both the 2 and 3. Now, it's not actually being distributive. This isn't a distributive property, but it kind of feels like it. So what we're really doing is we're saying that this 2 applies to everything inside the parentheses. So 2 times 3 squared, as long as there are parentheses, means 2 squared times 3 squared. Okay, so that's really all I wanted to say. And if you look at the property over here, you can see that ab to the x equals a to the x times b to the x. Because a and b are together in the parentheses, this exponent, x, applies to both of them. So let's see how that actually applies. Let's try this one. Let's do 2x cubed. All right? So you should be able to find the answer without expanding it at this point, just realizing that this cubed applies to both the 2 and the x. Remember, cubed is a fancy way of saying to the 3rd power. You can think of it in terms of dimensions. How many dimensions does a cube have? A cube is 3-dimensional, right? So 3 is cubed, and a square has 2 dimensions, so 2 is squared. Anyways, if I were to apply this exponent to the 2, 2 to the 3rd is 8, and then x to the 3rd is x to the 3rd. So your answer should be 8x to the 3rd, because the exponent applies to both the 2 and the x. Expanding it, it makes complete sense. Check it out. If you expand 2x times 2x times 2x, basically you have 2 times 2 times 2, which is 8. And then you can see you have x times x times x, which is x cubed. Good. So try this one. Now I want you to pause the video and see if you can figure out what this one is. 3ab squared. Pause the video and try it. Well, you should have done this. Realizing that the 2 applies to the 3, the a and the b, so 3 squared is going to be 9, a squared is a squared, and b squared is b squared. Did you get 9a squared b squared? Now, if you don't like that, expand it. Check it out. 3ab times 3ab. 3 times 3 is 9, a times a is a squared, b times b is b squared. You can always expand it. You don't need to memorize these rules. You can expand it and figure it out. All right, the next one has a star by it because it's a challenge. I'm going to see if you can figure this out. 5ac squared cubed. Pause the video. What do you think? All right, this one was tricky because it actually has 2 properties in it. Not only are we using the power of a product property, but we're also going to have to use the power of a property, because right here we have the power of a power. So let's see. The answer should be the cubed applies to everybody. So I hope you didn't write 15, because 5 plus 5 plus 5 is 15. But 5 cubed means 5 times 5 times 5. And 5 times 5 is 25. Times 5 again is 125. So this will be 125. This cubed also applies to the a. So 125 a cubed. And this cubed also applies to c squared. And what is c squared cubed? Remember that? It's c to the 6. So you should have 125 a cubed c to the 6. Did you get it? Expanding it, it would look like this. This is 5acc. I'm expanding c squared into c times c. And now I'm going to cube it. So it's going to be 5acc and then 5acc. Now notice we have 5 times 5 times 5, which is 125. We have a times a times a, which is a cubed. And how many c's do you see? 6 of them. So it's c to the 6. All right, let's write down the rule. The rule at this point is easy. You guys are getting a hang of this, I'm sure. This is ab to the x. That exponent applies to everything inside. So ab to the x is a to the x times b to the x. And there you go. All right, let's do one more in this video. Let's do the power of a fraction rule. I like to call it the power of a quotient. And as you'll see in this next slide, the power of a quotient. Now remember, a quotient is a division, kind of like a fraction. A fraction is a division, a quotient is a division, so it's the same thing. So here we go. Let's do one that's numerical first. So 2/3 squared. Well, if you square 2/3, you're doing 2/3 times 2/3. So 2 times 2, which is 2 squared, 3 times 3, which is 3 squared, which gives you 4/9. The bottom line is that just like with the power of a product, also with the power of a quotient, you, in a sense, you distribute that 2. It's not really distributing, but that 2 applies to everything inside the parentheses. So see, it's going to become 2 squared, and it's going to become 3 squared, because the squared belongs to the 2 and the 3, because they're together in the parentheses. Well, let's try another one. What about if we had this? 2a over 3 cubed. Pause the video, try it. You should have this. You should have 8a cubed over 27. Yeah? Here's why. If you expand it, you get 2a over 3 times 2a over 3 times 2a over 3. 2 times 2 times 2 is 8. a times a times a is a cubed. 3 times 3 times 3 is 27. So that's it. What about this one here? Now this guy, I'm going to put a star by it because you're going to have to use more than one property for this one. So let's try it. We're going to try 2a squared over b squared. No. Let's go cubed. All right. What about that? You pause the video and try it. You should have 8a to the 6 over b cubed. Here's why. This a squared can be written as a times a. So it's 2 times a times a over b times 2 times a times a over b times 2 times a over b. So 2 times 2 times 2 is 8. Obviously, you see the 6 a's and you see the 3 b's, and there you go. So what happened here, remember, is we had, again, the power of a power. We had this friend of ours. So that's why I had to multiply the 2 and the 3 to make it a 6. Okay? All right, let's do one last one. No. We're going to write the rule. So that means that if you have a over b to the x, that x applies to both the a and the b. So it becomes a to the x over b to the x. No matter what a, b, and x are, that is what's going to happen. Okay, I'm going to pause this video right here and come back for the second video this week, in which we do the 0 exponent rule and the negative exponent rule. Dun, 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 dun. Scary.